Okay, there are two questions. Isn't doubling max size equals 1 to 2 the same as? Yes. For that thing, yes. Doubling is same as incrementing by 1. But you think about it. After that, incrementing by 1 means from 2 to 3 and then 3 to 4, whereas doubling means from 2 to 4, 4 to 8 and so on. The first two cases are the same, doubling and incrementing by 1 are the same, but later on it's going to be different. Okay. Then what programming software should we use? So software means, like, you could use anything like Eclipse or what is that, NetBeans, or I use Notepad++. Yeah, so anything that will work for you is fine. As part of the submission, I want you to submit only a C++ file. So if you use any environment, it will come up with some other files too, right? So I don't want you to submit all those files. Just submit the basically what they call the raw code, or that's just a code, the C++ file, not anything else. You don't need to submit the executable or any other files that comes with your compiling environment. Okay, and submit the C++ file as well as some documentation files I would have asked. So let me pull up that assignment if I have it here. Okay, so I say submit the code as a separate file. That means submit a C++ file corresponding to case 2, submit your C++ file corresponding to case 3, which I have explained in the assignment description, and then I ask you to submit some screenshots and some explanation and some tables and all those things. So what I suggest is take screenshots and put them in a Word document and type your explanation in the Word document, include your tables in the Word document, and submit and convert that Word document finally to a PDF file. So I want a single PDF file that has all these items 3 through 8, not separate attachments. Okay, so you should have submitted things in Canvas before. So basically only 3 attachments for this assignment. One attachment for part 1, the code and this code, case 2 and 3, and then one PDF file that has the rest of the stuff. So that's the format we'll follow in the other assignments too. The code submitted separately, and then everything else submit as one PDF file. Okay. Alright, so let us continue. So let us focus now on the delete operation. So again, this is the list class. These are the member functions of the list class. So I want to delete an element at a specific index. Okay, and let us see the code for that. So this is having a code with a for loop and end of array minus minus. So that's what I'm going to show here in this slide. So let us again use this example and go over this code and try to understand how it is done. So I have a list of max size to be 8. End of array is 4. That means I have elements from index 0 through 4, and I want to delete the element at index 2. So basically I want to get rid of this 13 at index 2. So after this function, the list should look like this: 10, 23 followed by 17, 37. So 17 should have been shifted to index 2, 37 should be at index 3. And let us see how we really accomplish this. Okay. Alright, so start with this for loop. Index equals delete index. So index equals 2. Index less than end of array. End of array is 4. So 2 less than 4. Yes. So we come inside and say array of index equals array of index plus 1. So array of index, which is 2, equals array of index plus 1, which is 3. So I'm copying basically the value at index plus 1 to index. So I'm copying the value at index plus 1, which is 17, to index, which is 2, index 2. So this 13 is going to be overwritten with this 17 value next to it, to the right of it. Okay, so 13 is getting overwritten with the value to the right of it. And index is 2, increment index is 3, 3 less than end of array, which is 4. So I can still go inside and set an array of index equals array of index plus 1. So index is 3, and I'm copying to it or overwriting that val index with index plus 1. So index plus 1 is going to be 4. So I'm going to write this 37 to index 3. So at index 3 you're going to have 37. So the 17 which was there is going to be overwritten with 37. So index is 3 incremented to 4, 4 less than end of array, which is also 4. Not true. 4 less than 4 is not true. So we come out of the loop and say end of array minus minus. So end of array is now decremented from 4, it is 3. So this is how the array will look like after you come out of the delete element function. Now you may think the array is like this. I have not yet get rid of this 37. We don't need to, because what we want to accomplish is delete the value at insert index, which is delete the value at delete index, which is 2. So after the deletion, the list should look like 10, 23, 17, 37. And remember the definition of end of array as mentioned in the beginning. End of array indicates what's the index of the last element in the array, also the last accessible element in the array, right? So index positions ranging from 0 to end of array indicate the accessible portion of the list. So, and that's what it is. So 0 to end of array is 3 is the accessible portion of the array, which also means the accessible portion of the list. So this 37 will be still hanging out there. But if you want to now insert, right, at the end of the array or even anywhere in the array, what will happen? This 37 is going to get overwritten with whatever the new value you want to insert. So that will be still there, but using our convention of this end of array indicating the last accessible portion of the array, this is now basically our accessible portion, and that's the contents of the list. You should not say the list currently has 10, 23, 17, 37, another 37. No, the list has only 137 here. Okay. Is that clear? Any question on this, on the logic for the delete element function? Okay, so let us continue. Looks like somebody had a question. This will not be in your study session on Friday. Study session on Friday will be on module 1. Okay, so where we analyze the time complexity and using the big O and theta notation. Of course, I'm recording the video for this using Canvas as well as the YouTube. I'm going to post it, and I'm asking every time people have any questions. So if you have any questions, feel free to ask right away. Alright, so let us look at the time complexity, the best case and worst case. Alright, so the best case will be again deleting at the end of the list. So let us say this is my list, the array of 8 elements, end of array is 4. If I say I want to delete at the end of the list, means delete index is 4. So with delete index as 4, let us go through this code again. Index equals delete index 4, 4 less than end of array. End of array is also 4. 4 less than 4, false. So we don't go inside the for loop at all. Just come out and say end of array minus minus. So end of array is decremented from 4 to 3. And that's it. That's the delete element code. So that means to delete the element at the last index, all we just do is decrement end of array, and we are able to accomplish what we want. This is the accessible portion of the array. So just in what is called constant time, we really don't need to go through the iteration process. In just one decrement operation, we can delete the element or basically, yes, so delete the element at the end of the list irrespective of the list size. The list could have 1 million elements. Still, we could delete the element at the end of the list by just one decrement operation. So this goes back to our time complexity analysis. So it's called constant time complexity. Irrespective of the size of the list, we could accomplish the delete operation with just one decrement operation, end of array minus minus, if we want to delete at the end of the list. So deleting at the end of the list can be accomplished in constant time. Similarly, the previous best case. So inserting at the end of the list can also be done in constant time, because we don't really go through this for loop. All we do is one copy operation and one increment operation. And irrespective of the size of list, your list could have 1,000,000 elements. If you want to insert one more element, and that is to be at the end of the list, we can do that in constant time, just using these two operations. So constant time means the same number of operations irrespective of the size of the list. So irrespective of the size of the list, we can do these two operations and insert at the end of the list. So two operations, but still we say theta of 1, because 2 can also be written as, because any constant can be written as theta of 1. And here only one operation, but irrespective of the size of the list, so we can still say the theta of 1. Okay. Now the worst case. So the worst case, like insertion, also will be at deleting at index 0. So let us now again go through this code to see how would you delete something at index 0. So the same array, index equals now delete index, which is 0, 0 less than end of array, which is 4. So we come inside the loop and basically copy the value array of index plus 1 to array of index. So index is 0, so we'll copy the value from its right. So index plus 1 will be 0 plus 1, 1, so we'll copy the value to index 0. So 23 is copied at index 0, so 10 is now overwritten with 23. Then the next iteration, index will be 1 less than end of array, which is 4, which is true. So index is 1, index plus 1 is 2. So copy the value at index plus 1 to index. So 13 is written at index, which is at index 1. So 23 is overwritten with 13. Now index is 2, index plus 1 is 3. So copy the value 17 to its left, to index 2. And keep going. So now index is going to be 3, copy the value 37 to its left, which is at index 3. So now increment index will be 4, 4 less than end of array, which is also 4, not true. So we come in outside and say end of array minus minus, so end of array is now 3. So once we specify end of array is 3, that's the last index of the last accessible element. So that means the list now currently has 0, 1, 2, 3 as the accessible index values, and these are the entries of the list. So we started with this list and we deleted the element at index 0, which is element 10, and the list has the rest of the elements 23, 13, 17, 37. Okay. Now in terms of time complexity, how many times you are copying, that indicates the that's the basic operation for this deletion. You see that this is another example to understand the time complexity analysis. What is something we do repeatedly? In terms of time complexity, we copy the value. This copy operation is the basic operation we do repeatedly. So we say array of index equals array of index plus 1. So we copy the value at index plus 1 to its left. That's what is done repeatedly. And how many times we do the copy operation? One time for index 0, once for index 1, once for index 2, and once for index 3. So we basically copy 4 times, and which is n minus 1, right? So correspond to end of array. So we copy 4 times, right? So 4 is end of array, and end of array can be at most n minus 1. We saw that earlier. So the best case is one operation, which is this decrement operation, and that is different from the copy operation which we do for the worst case. So the best case is different from worst case, so we can use only the big O notation and write the worst case time complexity. This is the number of times we will do the copy operations at the worst case, n minus 1 times. So we cannot again have more than one term. We discard the lower order term and just say it is big O of n. That's the time complexity for the delete operation. Okay. Any question on this, the delete function? Okay, so let us see the other functions. Okay, so some other functions we can have in the list class, or to read at any specific index, we can say array or return. So I can say read and call the index I want to read. So if your list is this, if we want to read the data at index 1, I can call read of 1, and that will return array of 1, whatever the value at that index it is. Now if I want to modify the value at a specific index, I can call this modify element function, and that's the index and the data. So if I say instead of 23, I want to overwrite that value with say 30. I don't want to delete or insert, I just want to overwrite. That's what I mean by modify element. So at index 1, I can overwrite this with 30. So I can simply do that by telling array of, because the array is the base pointer that has the base address. So array of index equals the data. So that will accomplish what we want. Now if I want to count the number of elements in the list, instead of writing this code I have here, we can simply return end of array plus 1, because end of array really stores the last accessible index. So, and indexing starts from 0. So I can say if I want to get the count on the number of elements in the list, simply return end of array plus 1. In this case it will be 5. That's the number of elements in the list, and that can be done in constant time, because irrespective of the size of the list, if your list has 1 million elements, you can just return end of array plus 1. That is like plus the arithmetic operation is the only operation we do every time, irrespective of the size of the list. Now I show this code just to because this is the list class, right, implemented using as an array. After this we are going to implement the list using a linked list data structure, and there we don't have something like end of array to keep track of how many elements are in the list. So there we have to use a for loop to really count the number of elements in the list, and that's the logic I want to introduce right now, so that there we can really compare the two functions. So if we want to count how many elements are in this list, just write a loop and set a local variable say count to be 0, and run the for loop from index 0 to index less than or equal to end of array, because that's the accessible portion ranging from 0 till end of array. That's the last element. And then every time we go through this index, we do count plus plus. So index equal to 0, count is incremented from 0 to 1. Index equal to 1, that's the second element. Index equal to 2, that's the third element, fourth element, and then the fifth element. So once we reach the fifth element, which is index 4, we come out of this loop and return count. Okay, that's how we count elements in the list. Then so what we saw so far is the list class. We can have a main function that's at the user level, how the user uses the list class. So the user may want to create a list of a specific size, so I ask the user to enter the list size. So let us say the user enters say 8 as the list size. You see I specify, so this is the way you create the object of list class. So list is a class name that we went through the code for. So let me show you the actual code since we have it here. So list is the class name, and we went through all this code right now so far. Okay, so now I am the main function, and I am creating this integer list as an object of the list class. Now even though the user may want to create a list of 8 elements, I don't specify 8 as the size of the list. I can start it with one element. Okay, and so you're implementing as an array here, right? So you are going to create of an array of size 1 and then go through a for loop to insert values to that list. So you really want to create a list of 8 elements, and you can fill up with 8 values, and that's what this for loop is doing. It runs from index I is equal to 0, I less than list size, and for each value you want to add to the list, you ask the user to enter the value. You can call the insert at index function on this list object, integer list dot insert at index. So you start with inserting at index 0, pass the value. Now the list currently has space for only one element. If you want to insert one more element, what the insert at index function will do, it will first resize the list. That means create a new block of array and copy the previous content block of array content to the new content, and then it will insert. So the insert at index function will take care of all these things. At the user level, you don't have to worry about that. You can specify that I want to create a list of 8 elements, and if you want to be conservative, start with a list of just one element size, and then as you insert, keep inserting, the list size will be automatically adjusted, resized. So at the user level, you don't have to worry about resizing. The insert at index function will take care of. So this is again the difference between ADT and the data structure level. So this is at the ADT level how we are using the list ADT. Whereas how this ADT is implemented using an array in this case, and how the array is handled to take care of the insert at index is inside the insert at index function. And this is the coding at the data structure level, which is in this case the array. And then you can do the other things like delete index, delete at a specific index, read, and all those stuff. So I have posted all this code in Canvas too, so go through all this code. So one last thing before we complete this. So if you look at this, what we went through, the advantage with this approach of implementing a dynamic list using an array is, since we are using an array, remember the use of the base, the pointer that stores the base address of the array. We can read or modify an element at a particular index in constant time instead of one time, meaning that you could have an array of 1 million elements. Still, we can just say return array of any index, like 5000, index is 5000 or 10,000, 10,000, 100, whatever the number. So that is constant time, right? So that's the advantage you get with array, because using the base address you can access any index of the array in constant time. Now the disadvantage is the time that is involved in inserting or deleting, especially at the beginning of the list. Okay, you have to spend big O of n time. The other disadvantage is this. When we double the array size, we saw from a time complexity point of view, that's really better because you spend theta of n time instead of theta of n squared time. And also the actual number of memory cells that are allocated are going to be fewer with doubling. But there's one other potential problem with doubling is, remember, we need contiguous blocks of memory to deal with arrays, right? So since we are still working with arrays, instead of 4 contiguous blocks, now we need 8 contiguous blocks. And then if you're doubling again, you need 16 contiguous blocks of cells to store 16 integers. And then if you're again doubling, you need 32 contiguous blocks. Contiguous means continuous blocks, like starting from a specific address, 600, 604, and so on. Now, remember, this is not the only application or program you're going to run in your computer. You're going to run several other applications, and the memory may be kind of allocated to all those applications. So it might be difficult for the operating system to find a contiguous block of memory, say, that can hold 1 million elements if you're going to store and create an array of 1 million elements. So as your list size increases and you want to implement the list as an array, it might become a bottleneck. You may not be able to find space to hold consecutive to find you may not be able to find consecutive blocks of memory that can hold that many elements or space for that many elements. Okay, so that is like a bottleneck with implementing a dynamic list as an array. So next class what we are going to do is look at the second solution, which is the most preferred solution of using a linked list, especially if you want to store a larger list of more elements, and if you want to also insert delete more frequently. And once we finish linked list, we'll compare again the two approaches using array and linked list, and basically you will find that the array approach is better if you want to read or modify most of the time the list. So you create a list first, and then at the user level you will be more like reading and modifying the list. You will not be inserting or deleting. If that's what you want to do, implementing as an array is better. Whereas the linked list approach will be preferable for these cases. The disadvantages will be taken care of with an array, will be taken care of with a linked list approach. That means if you want to do more insertion or deletion, or if you want to store more elements in the list, you can use the linked list approach. Right, so we'll also look at this code to begin with next time, and then we'll look at linked list next class. So with that we'll complete today. So stay on, let me just mark your